Welcome back to our series on electricity regulation for transmission utilities. In our previous video, we provided an overview of key performance indicators and their importance in regulating transmission utilities. Today we're diving deep into two crucial categories of metrics: reliability and availability. These metrics are at the heart of ensuring that electricity is consistently available when and where it's needed.
Reliability metrics measure how consistently the transmission network provides power without interruptions. Let's explore the most common reliability metrics used across our focus jurisdictions. System Average Interruption Duration Index, or SAIDI. This metric is defined as the average outage duration for each customer served. It's calculated by taking the total duration of all customer interruptions and dividing it by the total number of customers served. SAIDI is used in the US, EU, and Australia, where it's known as USAIDI, which stands for Unplanned SAIDI. Its importance lies in the fact that it directly reflects the customer experience of outages. System Average Interruption Frequency Index, or SAIFI. This metric measures the average number of interruptions that a customer would experience. It's calculated by dividing the total number of customer interruptions by the total number of customers served. SAIFI is used in the US, EU, and Australia, where it's known as USAIFI, which stands for Unplanned SAIFI. The importance of this metric is that it indicates how often the average customer experiences a power outage. Energy not supplied, or ENS, is defined as the total amount of energy that would have been supplied to interrupted customers if there had been no interruption. It's calculated by summing up the interrupted power and the duration of interruption for all incidents. This metric is used in places like the UK, specifically by Ofgem, and also in the EU. ENS is important because it quantifies the economic impact of outages. Average interruption time, or AIT, is defined as the average duration of a single interruption. You calculate it by taking the total duration of all interruptions and dividing it by the total number of interruptions. This metric is used in various EU countries. AIT is important because it provides insight into the severity of typical outages. Momentary Average Interruption Frequency Index, or MAFI, is defined as the average number of momentary interruptions per customer per year. To calculate it, you take the total number of customer momentary interruptions and divide it by the total number of customers served. This metric is used in the US and some EU countries. MAFI is important because it captures those brief outages that may not be reflected in other indices like SAIDI or SAIFI.
Jurisdictional comparisons. Let's compare how these reliability metrics are applied across our focus jurisdictions.
United Kingdom Ofgem, primary focus on ENS, also uses number of loss of supply events, incentive and penalty scheme based on performance against targets. United States, EFERC states SAIDI, SAIFI, and MAFI are widely used. Specific targets are often set at the state level. Some states use performance-based regulation tied to these metrics. Australia, AER, uses USAIDI and USAIFI, which are the unplanned versions of SAIDI and SAIFI. It also measures the frequency of loss of supply events. The Service Target Performance Incentive Scheme, or STPS, ties financial incentives to performance. India, SAIFI, focuses on transmission system availability. It uses a target-based approach with financial incentives tied to meeting those targets. The European Union varies by country, but SAIDI, SAIFI, and ENS are common metrics. EU-wide reporting allows for cross-country comparisons.
Availability metrics. While reliability metrics focus on outages, availability metrics measure the readiness of the network to transmit power when needed. Key availability metrics include transmission circuit availability. Definition: the proportion of time transmission circuits are available for use. Calculation: total possible hours minus outage hours divided by total possible hours multiplied by 100%. Used in Australia, the UK, and India. Importance: indicates the overall readiness of the transmission infrastructure. Transformer availability definition: the proportion of time transformers are available for use. Calculation: similar to circuit availability, but focused on transformer equipment, used in various jurisdictions as part of overall availability calculations. Importance: transformers are critical components in the transmission system. Average circuit outage duration definition: the average duration of circuit outages. Calculation: total duration of all circuit outages divided by the number of outages. Used in UK, some EU countries. Importance: provides insight into how quickly issues are typically resolved. Planned outage rate. Definition: the proportion of outages that are planned, like for maintenance or upgrades. Calculation: number of planned outages divided by the total number of outages. Used in various jurisdictions. Importance: helps distinguish between planned maintenance and unexpected failures.
Jurisdictional approaches to availability. United Kingdom Ofgem focuses on network availability as part of the RIIO framework. It includes both planned and unplanned outages in their assessments. United States transmission availability is often reported to FERC. Some regional transmission organizations, or RTOs, have specific availability targets. Australia's circuit availability is a key metric in the Service Target Performance Incentive Scheme. There are different targets for critical and non-critical circuits. India, CIRC, transmission system. Availability is the primary metric. High targets, often 98 to 99%, with financial incentives for meeting or exceeding them. European Union approaches vary, but many countries track circuit and transformer availability. Some focus on cross-border transmission capacity availability to support the integrated EU energy market.
Challenges and considerations. Balancing reliability and cost. Improving reliability often requires significant investment, which can impact consumer prices, changing energy landscape. The growth of distributed generation and renewable energy creates new challenges for maintaining reliability and availability. Extreme weather events. Climate change is increasing the frequency and severity of weather-related outages, challenging traditional reliability metrics. Cyber threats. As grids become more digitalized, the risk of cyber attacks affecting reliability and availability increases. Aging infrastructure. Many countries face the challenge of maintaining reliability with aging transmission assets.
Future trends. Increased granularity, moving towards more localized reliability metrics to address specific network constraints. Real-time monitoring, advanced sensors and data analytics are enabling more dynamic reliability and availability assessments. Resilience metrics, developing new metrics to measure grid resilience against extreme events and long-duration outages. Integration with renewable metrics. Reliability and availability metrics may evolve to better capture the challenges of integrating variable renewable energy sources.
Conclusion. Reliability and availability metrics are fundamental to ensuring that transmission utilities deliver consistent, high-quality service. While the specific metrics and targets may vary across jurisdictions, the underlying goal remains the same: a transmission network that customers can depend on. In our next video, we'll explore efficiency and infrastructure development metrics, examining how regulators incentivize utilities to minimize losses and invest in network expansion. Thank you for watching, and we'll see you in the next installment of our series on electricity regulation for transmission utilities.